Good afternoon to all my dear friends. Today we will discuss chapter 12 Electricity of class 10th NCERT. So my name is Utkarsh Jadhav. Welcome to your own channel Utkarsh High Classes. So in today's topic we will discuss electricity. So electric current and circuit. We are familiar with air current and water current. We know that flowing water constitutes water current in rivers. So as you are also familiar with air current and water current. What is meant by air current? The moving air is called air current. And water current means what? Water current means moving water. It's called water current. So friends, where does the water current is available? Water current is available in rivers, in oceans, in seas. Here water current is available. So they are saying that we know that flowing water constitutes water currents in rivers. So in rivers water current is constitute. Similarly, if the electric charge flows through a conductor, for example a metallic wire, we say that there is an electric current in the conductor. So if electric charge is passed through the conductor, we say that there is an electric current flowing through the conductor. Means if you take any metallic wire or metallic rod and pass some electric charge through it, we will say that the electric current is flowing through the conductor. So what is meant by conductor? The conductor is the substance which allows the electricity to pass through it. So if the conductors are substance which allow the electricity pass to it, so the substance is also present which will not help the electricity to pass through it. So that conductor is called an insulator. That substance is called an insulator. So now we will move on next. In a torch, we know that the cells or battery when placed in proper order provide flow of charges. So in the torch, if we will put some cells, then the cells will flow the charges through a torch and torch bulb glows. So why does it glows? It glows because charges are flowing in it, and when charges flows, electric current flows through the torch. So the torch bulb glow. We have also seen that the torch gives light only when it is switch is on. We have seen if we will switch off, did the bulb glow? No. When we will switch on, then only the bulb will go. We should switch on the switch, then only bulb will glow. How do we express electric current? Now we don't know how we should express electric current. Now we will see next. Electric current is expressed by the amount of charges flowing through a particular area in a unit time. Means if you will take one rod and you will pass some electric charge through the rod. So in a unit time, how much electric charge you are passing through the rod is called electric current. How much electric charge you are passing through the rod in a unit time is called electric current. So this is expressed in the ampere, we will see next. So in the other words, it is a rate of flow of electric charge. So as we have seen, electric current per time came means the rate of flow of charges. Because what we have seen, electric current means the amount of charges passing through a area through a unit time. Amount of charges passing through the area through a unit time. Here unit time means per second. And where per second came, the rate of flow will also come. The rate of flow of charges is also called electric current. We can use metallic wires. In metallic wires, electrons constitute the flow of charges. So in metallic wires, electrons constitute the flow of charges. What constitutes the flow of charges? Yes, electrons. Electrons do the flow of charges in the metallic wires. However, electrons were not known at that time when the phenomenon of electricity was first observed. So when the phenomenon has been observed of electricity, at that time no electrons were discovered. At that time, no electrons were discovered when the phenomenon of electricity was first observed. So, at that time, conventionally positive charge were taken the direction of electric current. At that time no electrons were there. At that time positive charge were taken as the direction of electric current. So conventionally at that time in an electric circuit the direction of electric current is taken as opposite to the direction of flow of electrons. Means conventionally the electric current will go in one direction, then the maximum that the flow of electrons will go to the opposite direction. Means electric current is in right, then flow of electrons will be left, means opposite direction. And as we know that electrons are negatively charged particles. So now if we will go on next, if a net charge q, now we will represent charge as q, flows through any cross section of a conductor in time t, then the current I through the cross section is. So when we will pass a charge q through a time t, then the current I through the cross section is. If we will produce some charge q in the time t, then the current is produced as current is equal to charge by time. So I is equal to q by t, and this is our first formula for the electricity chapter through the cross section. So the SI unit of electric charge is coulomb. So SI unit of electric charge is coulomb, which is equivalent to the charge contained in nearly 6 into 10 to the power of 18 coulombs. So SI unit of electric charge is coulomb, yes, right? Yes. So which is equivalent to the charge contained in nearly 6 into 10 to the power of 18 electrons. Means the coulomb, 1 coulomb is equal to the charge of 6 into 10 to the power of 18 electrons. Means when we will constitute the 6 into 10 to the power of 18 electrons, we will get 1 coulomb charge. So we know that an electron possesses a negative charge of 1.6 into 10 to the power of minus 19 coulombs. So 1 electron possesses a negative charge. We know that it possesses a negative charge, and we will take it as minus 1. But here the correct value is minus 1.6 into 10 to the power of minus 19 coulomb. Observe here carefully, it is a negative charge of 1.6. So we should take here minus 1.6 into 10 to the power of minus 19 coulombs. So the electric current is expressed by a unit called ampere. So we have seen that electric charge is measured by coulomb. SI unit of electric charge is coulomb. So the SI unit of electric current is ampere. SI unit of electric charge coulomb. SI unit of electric current ampere. Ampere is denoted by A, coulomb is denoted by C, the first letter of the word. So why this ampere is named as ampere only? So one scientist were there, Henri Marie Ampere, whose birth date was 1775 and he died on 1836. So he discovered the electric current and his name is there for the 1 ampere, for the SI unit of electric current, because he discovered the electric current and he kept the name. So 1 ampere is constituted by the flow of 1 coulomb of charge per second, that is 1A is equal to 1C by 1S. So here what it is saying that 1 ampere means how much? Now we have seen that 1 ampere is 1 coulomb by 1 second. 1 ampere is 1 coulomb by 1 second. So as we know that I is equal to Q by T. What is meant by Q? Q is known as electrical charge. So charge unit is coulomb. So we will substitute SI unit of Q is coulomb. SI unit of T is second. And SI unit of I means electric current is A, means ampere. So in this formula only we will get 1 ampere is equal to 1 coulomb per 1 second. So small quantities of current are expressed in milliamperes. So here small quantities of current are expressed in milliamperes. 1 milliampere is equal to 10 to the power of minus 3 angstrom. A is here angstrom, not ampere. 1 milliampere is equal to 10 to the power of minus 3. Sorry. 1 milliampere is 10 to the power of minus 3 ampere. Yes, not angstrom. It is 10 to the power of minus 3 ampere. My mistake. Or in microampere, 1 microampere is equal to 10 to the power of minus 6 ampere. So an instrument called ammeter measures electric current in a circuit. So in a circuit, the device called ammeter is used to measure the electric current. Ammeter is used to measure the electric current and voltmeter is used to measure potential difference. We will see in next. So in figure 12.1, it shows a schematic view of circuit diagram with. So this shows an schematic view of circuit diagram. This is bulb, this is ammeter, this is plug key. I will decrease the font size. Please wait. Okay. So this is bulb, this is ammeter, this is plug key. On position, this is a battery of 2 cells, and here the current is going as it is shown here, I. So here ammeter is used to measure the electric current. So friends, ammeter is used only in a series connection. How I will show? Here is a series connection. If here is the bulb. So this is a series connection. If here is one cell, here is one cell, and here is one ammeter. So if in the series connection means in a series ammeters are located. So see, an instrument called ammeter measures electric current in the circuit. It is always connected in a series. There are two types of connection, series and parallel. We will run. So one type of series. So ammeter are located only in the series. If it is located in parallel, it will get burst. So now figure 12.1 we have seen. This is a schematic view of the circuit diagram with the cell, an electric bulb, ammeter, plug key, battery, etc. So this is very important. This maximum questions asked for the exam is between this. Note that the electric current flows in a circuit from positive terminal to the cell to the negative terminal. So now we will see here. It flows from positive terminal to that of negative terminal. So here from onwards, the electric current is flowing to here. Like this it is flowing. So now we will see here, as electric current is flowing from here to here. So they will ask that what is the direction of electric current in an closed circuit. So they will give option from positive terminal to the negative terminal, from negative terminal to the positive terminal, both A and B, or none of these. So correct answer for this is from positive terminal to the negative terminal. Electric current flows from positive terminal to the negative terminal. So of the cell through the bulb and ammeter. So here the electric current is flowing. Here the electric current is flowing through bulb and ammeter, plug key and battery. So this is, now we will discuss example number 12.1. So a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. So here this is an filament ampere. Here they have given I is equal to 0.5 ampere. So this is an current. So T is equal to 600 seconds. 10 minutes they have converted into seconds. 1 minute is equal to 60 seconds. So 10 minutes is equal to 600 seconds. So friends, do you remember what is our first formula for this electricity chapter? Here is it. I is equal to Q by T. So same formula we are going to apply here. I is equal to Q upon T. So here What is the Q? Q is equal to I into T. So we can bring T here. So Q is equal to I into T. So then we can substitute it and we can find our solution. So Q is equal to I into T. I value is 0.5 ampere. Means electric current value is 0.5 ampere and T value is 600 seconds. So answer is 300 coulombs. So this is for today, my dear friends. Next part of electric potential and potential difference we will discuss in next video. Thank you and have a nice day.